Steering and suspension inspection is something that should be part of almost every service we as technicians provide our customers. Because after all, not only is this componentry critical in terms of safety for our customers and those they share the road with, but it also plays an important role in how the vehicle handles, as well as how the tires wear. But while careful inspection of steering and suspension components is an important service we provide, how we inspect those components to get an accurate diagnosis is just as important. So stick around, because that's the topic of this Motor Age Tech Tip. This Motor Age Tech Tip is brought to you by bproauto. It's no secret that suspension components like ball joints and tie rod ends encounter some punishing loads and abuse during even normal day-to-day operation. And just like many joints in the human body, suspension components need to articulate in a multitude of directions, while often, like in the case for many ball joint designs, carrying the load of the vehicle. And they're required to do this over many, many miles. So how these joints exhibit wear and how we check for that wear will differ depending on the suspension design. So let's first take a look at ball joints. But before we can correctly examine a ball joint for wear, we need to understand the main ball joint types and how they differ. The first design that we will look at is a follower ball joint design. A follower ball joint is simply a ball joint that really only absorbs radial loading, meaning it's there to help to keep the wheel and the tire aligned, but it carries no real axial load. The easiest way to illustrate this would be looking at a basic McPherson strut design. The loaded strut assembly with the bearing plate, the spring, and then the strut itself, that contacts the knuckle, which is bolted to the hub assembly, which the wheel is then bolted to that. The weight of the vehicle is carried through that path. So when it comes to the lower control arm and ball joint, its job is really just to keep that wheel aligned rather than both keeping the wheel aligned and supporting the weight of the vehicle. Next, there's load carrying ball joints. These are joints that not only need to maintain radial alignment, like the follower joint, but they're also responsible for axial loading as well. And while there are many different designs, they really can fall into two main categories based on how the loads act upon that joint itself. The first example would be a compression loaded ball joint. It's called this because the weight of the vehicle will run through this ball joint, and its orientation in the control arm and the knuckle is going to cause the weight of that vehicle to compress that joint together. The next design is the tension loaded ball joint. So much like the compression loaded design, these ball joints carry both radial and axial loading. But this design, the loading of the joint is actually trying to pull the ball stud out of the housing. So you're probably asking yourself, why is this important? The reason the design is important is we need to understand how loading affects these joints in order to properly check them for wear. The way you go about checking a GMT 900 pickup is going to differ from a JK Wrangler. And fortunately, service information will outline correct procedures as well as go, no-go replacement thresholds for movement within these components. So let's take a look at proper vehicle service procedures for these two common vehicle types. When it comes to checking ball joints on vehicles with SLA or short, long arm suspension types, most service procedures will require the lower control arm to be supported. This is to align the ball joint in a manner that mirrors its geometry when the weight of the vehicle is on the tires. We want that ball joint to be in a natural position so we can accurately determine true ball joint wear. So in a common application like a GMT 900 series pickup, service information requires that the lower control arm be jacked to at least 1 inch of movement. This is to align the upper and lower ball joint to where they need to be. From there, the specification for both the lower and the upper ball joint on this application is 20 thousandths axial, meaning up and down movement. Vehicle manufacturers have specific requirements for replacement, so dial indicator usage is important. Solid axle, like what you'd find in something like a Jeep Wrangler, have a little different design. The axial load-bearing ball joint on a Dana 44, like in that popular JK Series Wrangler, is the lower ball joint. The upper ball joint is simply a follower design. Also, a solid axle can often incorporate a telescoping designed upper ball joint. So found in many Jeep and Ram applications, the telescoping design allows for manufacturing differences between the axle itself and the knuckle. This helps reduce issues like binding and memory steer. That is why looking at service information is so important, because many of these applications will have play in the upper joint right out of the box. So dial indicator usage is very important in solid axles as well. While additional supporting and jacking of the front suspension is not required, proper dial indicator placement is, so you can get correct measurements. Make sure, again, you are referencing service information, because like in the case of the JK with that Dana 44, the lower load carrying ball joint has a replacement threshold of 50 thousandths axial movement and 60 thousandths radial in the upper ball joint. So as you can see, there are plenty of considerations the technician needs to take when inspecting ball joints. Proper inspection goes well beyond simply throwing the vehicle in the air and just grabbing a tire looking for any perceivable movement. And remember, while this video is concentrating on joints themselves, don't overlook things like control arm bushings, and if you're chasing a noise, keep in mind those sway bar links and bar to frame bushings as well. Now let's move on and look at steering component inspection. Whether the vehicle has a conventional Haltenberger or parallelogram style steering setup, or a version of rack and pinion, there are a few key things that you should keep in mind when inspecting for looseness on these components. Just like the ball joints that we spoke about earlier, these joints are often also a ball and socket design. So regardless of their design, keeping debris and contaminants out of the joint and the lubrication in is a key factor to their longevity. So make sure you are visually inspecting these boots and seals to make sure that they're still intact. And when it comes time to check for looseness in the joint, there are a couple of key things to keep in mind. First, if the joint is serviceable, meaning it has a grease zerk, it's best to check the joint for play before adding any grease. Also, we want to be checking the joint by hand, so don't use any large channel locks or pry bars. These joints control radial forces and are designed as such. So applying a heavy load, like a set of pliers, to squeeze that joint for play can apply forces in places it just wasn't designed for, and damage will be the result. Also, when checking the rack and pinion on a rack and pinion vehicle, give the rubber bellows that surround the inner tie rod end a quick squeeze. Oftentimes, a leak in the rack will be disguised by a well-sealing bellows, so make sure it's not full of fluid. Many vehicles with solid front axles, like the aforementioned Jeep Wrangler, are prone to suffering from severe shimmy, or what's commonly referred to as death wobble. This condition can happen for a variety of reasons, stemming from loose front end componentry to aftermarket components and alignment angles that are just outside the design parameters from the vehicle manufacturer. While there's a variety of reasons that can create this occurrence, remedying the situation starts with a thorough inspection of all the steering and suspension components before going immediately to aftermarket componentry, like larger steering dampeners or steering box braces. Otherwise, you could be turning to a Band-Aid solution that fails to address the root cause of the condition. Lastly, when you go to make your repairs, make sure again to reference service information to get proper torque specifications for what you're working on. And then use a torque wrench. Don't just hammer things like ball joints, pitmans, and idlers, as well as tie rods together with an impact. Today's guns, whether pneumatic or electric, are extremely powerful, and many of the materials that make up the taper that these joints seat into are lightweight and can easily be damaged by that over-torquing. And while on the subject of tapers, it's a good idea to check your tapers before putting everything together. The taper of the stud should mate snugly with what it goes into, with no lateral rocking movement able to take place. If looseness is encountered, replace the worn component. Catastrophic failure of the joint can result if the stud doesn't fit snugly and is allowed to move. And when it comes to replacing safety critical components, always use high quality parts like those from bproauto. utilizing sintered powder bearing technology to allow for self-lubrication of the bearing surface, and then greasable designs where available to help lubricate that sintered bearing and purge contaminants away from the bearing surface. Heat-treated, high-quality alloy steel and larger and precisely machined ball studs that provide for lower friction coefficients, more load capacity, and smoother operation. High-quality neoprene dust boots with multi-steel design that effectively prevent contaminants from entering the joint, even in the coldest of temperatures. Choose bproauto ball joints, tie rod ends, and other front-end componentry for OE quality parts for a fraction of the price. With coverage of over 160 applications, bproauto should have your steering linkage and ball joint needs covered for servicing Stellantis applications. I hope you have picked up on a few pieces of information that you didn't already know. Remember, the safety of your customers, their families, as well as you, me, and our families that all share the road together rely on safe and accurately diagnosed vehicles, especially when it comes to safely critical components like steering and suspension. As always, please leave any questions or comments below. I will do my best to address them. My name is Eric Screeden, and thank you for watching.